Welcome to ODA Summit 2021, and thank you for joining us today. My name is Neil Peterson, and I'm the president of Open Design Alliance. During the past 5 years, the ODA platform has been quietly undergoing a transformation. We've taken a set of individual format SDKs and evolved them into a unified platform that can solve an increasingly sophisticated set of interoperability problems. Our offering to the industry in 2021 is complete interoperability for CAD and BIM, and that's the theme for our conference this year. Our agenda today includes technical presentations from the ODA development team, real-world success stories from ODA members, special guests from Google and Building Smart International, and new this year will be a couple of panel discussions from industry experts that I think you'll find quite interesting. At the start of the pandemic last year, we made a smooth transition to work from home, and most of us are still in that mode. I hope that we'll be able to safely reopen our offices by the end of this year, but in the meantime, we've maintained an aggressive development schedule, and our team has performed well during a difficult year. Membership growth in 2020 was flat, which was not unexpected, but we finished the year strong, and 2021 through third quarter has been our strongest year on record for membership growth. The pandemic isn't over yet, but we're hiring aggressively, taking on new projects, and we see a bright future ahead for ODA. Narrowing in on BIM, industry experts expect the BIM software market to grow by 13% annually through 2024. Global infrastructure spending over the next 20 years is expected to be more than $90 trillion. Commodity prices are expected to rise more than 10% this year, and labor costs are increasing. At the same time, labor productivity growth in construction has been increasing at a rate of only 1% per year over the past 20 years, compared to 3.6% for manufacturing. There's a huge opportunity for companies that can improve the efficiency of the construction industry through digitization. We keep a close eye on long-term trends for the CAD and BIM industries. In the last 2 years, we've seen a clear shift in the requests coming from ODA members. Companies today are asking for integrated technologies, common workflows for data in any format, professional-grade visualization, support for open and proprietary standards, and they want everything to be available on the web. We continue to see strong demand for our core DWG, Revit, and IFC technologies, but more and more companies are looking for integrated solutions to address problems such as customizable design review. Complete interoperability is our solution to the evolving needs of the industry. Complete interoperability is a set of integrated technologies for working with CAD and BIM data. It's format SDKs on steroids. It includes common frameworks for visualization, publishing, and web collaboration, and we have our own solid modeler and facet modeler for working with complex 3D geometry. It's everything you need to build sophisticated CAD and BIM applications on any platform, including web. A fundamental part of ODA's mission is a commitment to Open BIM. ODA is a strategic partner of Building Smart International, and our goals as an organization are fully aligned with BSI. We participate in a number of BSI working groups to help advance the creation of Open BIM standards. Our Open BIM technologies include a comprehensive IFC toolkit, as well as support for BIM data exchange through the MVD, XML, and IDS standards. On the collaboration side, we now support the OpenCDE standard in our cloud platform. OpenCDE is BSI's new standard for common data environments, which includes workflows for issue resolution and document exchange. Finally, we have OpenIFC Viewer, our free viewer that integrates fast, professional-grade visualization with support for the latest IFC versions, along with clash detection, BCF issue resolution, and more. ODA offers the best and the most complete Open BIM solution on the market today, and we're committed to Open BIM for the long term. ODA has been making great strides with BIM, but we're also seeing strong demand for advancements in mechanical CAD. In a recent member survey, more than 50% of our members requested a solution for STEP, the standard exchange format for 3D mechanical CAD. In response to this demand, we recently began work on a new SDK for STEP. Our goal is to deliver a best-in-class solution with full data access and creation support, integrated visualization and publishing. Complex 3D geometry will be supported by our own native solid modeler, so there won't be any dependencies on expensive third-party modelers. And since STEP is an open standard, our STEP SDK will be available to all ODA members at no additional cost. ODA is in the process of joining PDES Inc., the organization that maintains and develops the STEP standard on behalf of the industry. STEP has been around since 1994. It's been a successful standard and one that's still growing and adapting to the changing needs of the industry. STEP is now part of ODA's strategic mission, and we're looking forward to delivering our new STEP SDK by the end of 2022. Laser scanning technology has been advancing rapidly in recent years. Even the latest iPhone has LiDAR capabilities. But you can't say the same thing about our ability to process the point cloud data generated by all of these really cool laser scanners. It's not enough to import a point cloud and use it for reference in a design tool. We need to be able to generate BIM models automatically from point cloud data. To address this problem, ODA has created a new strategic interoperability group for Scan-to-BIM. We're working collectively with a group of ODA members to develop technology for converting point clouds to 3D BIM models in IFC and Revit formats. With expertise in point cloud processing, complex 3D geometry, BREP modeling, and BIM technologies, ODA is well positioned to solve this critical industry problem. We have a group of special guests here today from major architectural design firms who will be giving us their insight into the challenges and requirements for Scan-to-BIM. Thank you for your attention. If you'd like to connect, my email address is president@opendesign.com. Enjoy the rest of the conference.
The first block of ODA Summit is dedicated to the product we've been developing for more than 20 years. One that's made ODA a synonym for interoperability in the CAD industry. The product is Drawings SDK, a universal CAD engine satisfying the development needs for a wide range of solutions, from simple data extractors to full-featured CAD editors. Drawings SDK is being used today in thousands of member applications by millions of end users. Drawings SDK supports two of the most popular CAD formats, DWG and DGN, along with comprehensive two-way conversion between these formats. It also includes complete data exchange with PDF, both for import and export. Drawings SDK is an actively developed project. We not only fix issues and add minor features, but we are also working on major new capabilities. This year we significantly improved conversion between DGN, DWG and PDF formats. We extended the set of 3D modeling operations natively supported in Drawings SDK without the need for any third-party libraries. These newly implemented features include Boolean operations on incomplete solids, support for tolerant topology, and complete sculpturing functionality. We enhanced ODA's unique DWG revisions technology used for storing drawings history in an optimal way. We added support for DGN metadata that provides access to custom data in DGN files, for example, BIM data, and we continue working on improvements to various entities. Now, we'll see an example of how a member is using ODA Drawings SDK in a real-world application.
Let us move on with our DWG, DGN and PDF triad and have a deeper look at the DWG area. DWG support has a long history, approved stability and well-known features. But we do not stop work and go on providing enhancements and new features on the regular basis. DWG support improvements were done in the following areas: fields creation and improvements for the following entities such as mLeader, hatches, associative arrays, polygon, and table entities. Objects creation from content strings was implemented for text, mText, dimension, and table entities. Expressions, object parameters, database variables were supported, including nested fields. On the screen you can see an illustration, a set of strings that were used as input and a set of objects that were created using those strings. Fields trees were created as a result of using codes as arguments for setting strings methods, such as setString, setContent, and setDimensionString. Fields trees are marked on the screen. You can see it. This approach is implemented in Model Doc project to create title texts. Improved visualization of true type fonts using Uniscribe Windows API allows to more accurately draw international characters that use diacritics, umlauts, and similar elements. On the picture you can see Arabic, Western, Hebrew, and Thai fonts. The differences are marked with colors: orange, old version, green, new version. Complex entities may have sophisticated behavior. When an application user drags a point that doesn't mean that only these point coordinates were changed, most likely some other properties should be changed and recalculated accordingly. As an example, we can have a look at the drag wizard that controls the directions of the aligned text. As you see, the direction of the text stays the same despite of all the changes of the arc. Another example is applied to formulas. Source data may have any format or maybe just a text string without any format, and it's very important for the new formulas to apply the correct format despite of the source data formats. In the table you can see the results of this improvement. DWF database is used for DWF underlays vectorization, for DWF imports and exports to DWF. This year we have two improvements. DWF 2D geometry markup support was implemented and DWF 3D support was improved. DGN support is also a mature ODA capability. This year we introduced three major advancements: support for associative dimensions and entities, full support for DGN metadata, and partial loading support. This demo illustrates automatic recalculation for associative dimensions and multi-line points associated with other elements. Metadata is an important part of BIM approach. It is a non-geometric data associated with the DGN element. It can contain information about the physical parameters, costs, relations between entities. Some operations with DGN files do not require access to all elements. For such cases, partial loading was implemented. Partial loading helps to save in memory only the position in the file and read the data from this position when we need access to this particular element. For PDF, 2 points are of key importance: export speed and resulting PDF file size. Now we're able to use WSCAD, and this helps us to divide the whole export procedure into two phases. The first one, vectorization, when we vectorize all elements to this cache, and the second one, displaying, when we display the cached entities to PDF file. The first phase may be processed in multi-thread mode, thus decreasing the export time. Complex DWG models may contain blocks, but there are similar block entities in PDF files. If we convert DWG blocks to PDF blocks, we get a set of advantages. They are quicker speed of export, the resulting PDF file size will be smaller, And additionally, processing of such files by PDF readers, for instance Adobe PDF readers, will be done quicker. PDF import area included 3 main directions for improvements: clipping support, text import, and widgets import. We added image clipping support to make the imported files as close to the original PDF as possible. For text import, we have 2 main enhancements: preferred text support and embedded text support. Preferred text support allows us to import text as text with any font we wish. Embedded font support means the following: if the embedded font is saved in the PDF document and fits TTF standard, it can be also saved and then used during the visualization of the imported DWG file. Complex PDF documents may contain widgets. Widgets import is designed to make the resulting document as close to the original PDF as possible. Widgets in this case are imported as a set of images, geometry, and text. In addition, we also implemented importing of hyperlinks from PDF and many other enhancements. Publish SDK consists of 4 main parts: 2D PDF export, 3D PDF export, PRC API, and Publish API. 2D PDF export is quite well known. 3D PDF export requires PRC model to be embedded in the document. PRC API actually can create or modify or work with PRC models. And Publish API allows you to create almost any type of PDF document. This document consists of several pages and contains all basic elements such as 3D view and 2D view combined on one page, custom UI controls, and 2D projections and section. One more example of an interactive document created using Publish API. On the bottom you can see the buttons to switch between the predefined views. On the side, you can see the part lists to select parts of the model, and you see that the selected parts are highlighted. Swig wrappers are already known to many of our members. We provide wrappers for C#, Java, and Python. C# wrappers have the widest coverage. This year, we provided wrappers for IFC SDK.
Microcad software is a company specialised in the development of interior design software. Our main products are AutoKitchen for kitchen, bathroom and bedroom design, and AutoDeco for commercial kitchens. Our programs have been based on an AutoCAD OEM for the last 23 years. In the recent years, we felt that the improvement for our software was limited by the kernel. If we analyse the advantages and disadvantages of using AutoCAD OEM, according to our experience, the main pros would be the following. Using an OEM AutoCAD engine instantly transmits more trust and is recognised worldwide by designers. AutoCAD is a powerful and reliable product, and it includes an ACIS modeler as the geometric modelling kernel, which is very powerful and reliable. Among their main disadvantages, we can highlight the following. The rendering engine is limited and has little evolution between versions of AutoCAD, giving us no ability to improve our renders between versions. The current render has not changed since the version of 2016. The video walkthrough module is the same as in AutoCAD 12. This technology is 30 years old. AutoCAD has only got GDI impression that doesn't show the print previous access it will be printed. And shadows and fast shade mode cannot be activated because there are problems with normal computers, such as those with appliance. The response time of the technical service is very long. The high cost based on royalty that have risen more than 15% in the last 3 years. We decided to use ODA to have more flexibility by developing our tools at a deeper level and by using third-party solutions adapted to our needs to enhance its functionality, such as powerful rendering engine with photorealistic walkthrough capabilities. The change to ODA gave us more flexibility in the development of AutoKitchen. The high quality of the technical support and speedy fixes also allow us to improve and develop AutoKitchen thanks to monthly version updates fixing reported bugs and issues. In addition, the updates take into account the developer's requests in contrast with the AutoCAD improvements that are focused on what the rest of the AutoCAD community needs. Finally, the payment of a fixed fee facilitates business management, especially when the fee is affordable and reasonable. The main drawbacks that we have encountered have been the following. Development is slower because there are tools that are available in AutoCAD, but that have to be developed by us in order to put them into ODA. The lack of rendering was an inconvenience, but at the same time, it was an opportunity for us to use a different rendering engine that was best suited to our needs. The solid modeler is much more basic than ACIS in AutoCAD. We developed the application using the ODA MFC application as an example as a basis, but it took more than a year to get AutoKitchen ODA to have the same look and feel as on AutoCAD. In the development, we found that we could use the DLLs with minor changes. Most of the blocks used in our libraries were valid, but some solids had to be redrawn as they displayed well in AutoCAD, but not in ODA. We spent most of the time on the user interface to make the program look like the AutoCAD-based program. The new ODA-based version of AutoKitchen works the same way as the old AutoCAD-based one. Here in AutoKitchen, we have a nearly finished kitchen to demonstrate some of the features and processes on the software. Before we render, we need to show the walls and ceiling that we previously hid, and then place the camera where we wish. We change to far shade and adjust the view of what we want to make a render of. Our rendering has 4 quality settings to choose from, and here we will select the far setting, which will generate a render usually under a minute on most designs. When we click render, the program exports all of the scene information from lights, geometry and materials and so on. The render is then generated and takes you to a render menu where you can make adjustments to the image with a range of modifiers like exposure, contrast and so on. In conclusion, we are happy to have made the change. Now we have a better program at an affordable fixed fee. We would like to highlight the quality and speed of the support service compared to our previous experience. After 2 years of development, we've created a new version of the program with the same interface as the version based on AutoCAD, so the customers have not noticed the change of the engine. The program has improved functionality, and the render engine we link with is easy to use and generates photorealistic images, 360 panoramas and videos with better quality that put us ahead of our competitors.
Hello, I'm Ilya from WSCAD. Recently, we released our new electrical CAD system that uses ODA components in its core. It was a quite long and challenging way. So the question is, why? Why replace an already working solution with something different? Does it really worth it? Well, let's figure that out. Speaking of electrical engineering, we should keep in mind that it doesn't exist in a vacuum. As input, we usually have a plan of building in DWG format. The main task is to extend the plan with electrical appliances from our data model. After that, we need to share the results, saving the change DWG back and generating the whole project documentation in PDF format. In our previous solution, we managed all the workflow by ourselves. What does it mean for customers and actually for us? First, we had to convert the content of the source DWG file to our internal data model. Of course, our data model is not complete enough, and a lot of original data like custom entities or dictionaries simply vanished during this conversion. Second task was to show the internal model on the screen for editing. And again, as we were far away from 100% DWG compatible, the result was slightly different to what was expected. For instance, line thickness might be not quite accurate, or text parameters and alignment was not always correct. Third challenge was to save the multi-page documentation in PDF. Well, I bet you already know what happened. The results in PDF look differently again. And finally, saving DWG files back was a complete disaster for customers. Despite the similar look, the inner structure of DWG was different after passing through all our workflow with many conversion steps. For instance, a custom hatch might be simply replaced with a set of lines and maybe texts. All of that was definitely bad for our customers, but it was also quite hard for us. Using different components for DWG interops, screen rendering and PDF generation forced us to write tons of glue codes, and that code was supposed to be able not only work properly but also to work around some specific of components we used. So instead of fixing 1000th bug dedicated to interoperability, we asked ourselves, maybe we can do better? And yes, we can. The general idea is to use ODA tech stack for the whole workflow I described earlier. ODA drawing is used to read incoming DWG files, not losing in details. Also, we have a performance boost here as a step of converting DWG to our internal data model is eliminated. You can simply open the DWG file and here it is. Showing a drawing on the screen is performed via ODA Visualize. And it's not only accurate in displaying content, as it's supposed to be, but it's also fast, thanks to GPU hardware acceleration. Third, saving DWGs back becomes a very simple operation provided by drawings technology. It's fast, reliable, and that is more important, it preserves the structure of the original document we got as an input. And then, export to PDF is performed via ODA Publish. Despite its quite simple 2D plans, there are a lot of aspects to think about. So, let's figure out why do we need PDF export. After all, we develop sophisticated software, so why not to use it as a viewer also? There are several reasons for that. Obviously, our software costs money. Also, it's pretty function-rich and therefore, well, more or less heavyweight. And also, it doesn't exist for all of the platforms yet. On the contrary, PDF is quite light, it's available everywhere, and it's free. So it's a really very, very important and useful exchange format. And despite it's just an exchange format, we shouldn't keep things stupid. We should help our users to deal with this drawing even not having access to our software. What does it mean? First of all, as we are producing multi-page project, the table of content is a must-have. And yes, we can do that. Second, we have a lot of electrical symbols on every page. Using annotations in PDF file, we can show users additional information of these symbols, like they're working with our CAD system. Then, all the pages in the document are not independent. A symbol from one page might be connected to something on a different page. Therefore, we provide cross-page references. You can click on a link on one page and instantly move to a connected page. So interactivity is really useful here. And last but not least, all the pages are generated in a CAD quality according to the what you see is what you get principle. So, as a result, our customers receive a lightweight, multi-platform version of our CAD just as a PDF file. So, switching to ODA solution allow us to achieve the following goals. Well, significant code-based simplification of our solution, of course. Performance improvement of DWG file opening and rendering and other interactive operations. True, what you see is what you get approach. Now everything a user sees on the screen looks the same in DWG or PDF. But most important, ODA allow us to speak the same language as the rest of the world. We can freely understand complex DWG files containing not only simple graphics primitives, but even architectural elements. And we can generate such complex files by ourselves too. And we can provide first-class drawing in PDF files to our customers, who even maybe don't have any CAD system on site. Thank you for watching.
ODA offers 3D modeling through our own natively developed facet and solid modelers. The ODA Facet Modeler was originally developed to support Architecture SDK, but now it's getting more frequently used, independent from architecture. This year, our main enhancements are related to bodies, the draw body function, true colors, texture mapping coordinates, and body conversion to OD-DB sub-D mesh. ODA Solid Modeler is a part of our kernel SDK. Several ODA products, including BIM-RV, Civil, IFC, and of course drawings, work with it. Solid Modeler works with BREP-based 3D objects and implements a set of modeling operations. This year, we implemented the following new features: sheet set Boolean operations on incomplete solids, and generation of a network surface from a set of cross curves. This should be finished by the end of the year. A network surface is a non-planar surface created in the space between several 2D or 3D curves in the direction of the U and V axes. The green and red lines are 3D curves in the U and V directions. Let's watch a short video demonstrating network surface creation. There is a group of 3D curves. For simplification, they are marked with different colors, and creation of the network surface is pretty simple. Select all curves in one direction, then in a second direction. Tolerant topology support is a feature that is worth special attention. Last year, Boolean operations for solid entities were open to ODA members in investigation mode. Members who use Boolean operations provided feedback, and we found that a lot of models have tolerant topology. Support of tolerant topology affects Boolean operations in Drawings SDK if input bodies were created outside of ODA SDKs. We implemented a new sculpture operation using the ODA Solid Modeler. The Sculpt operation creates a waterproof solid from a group of surfaces, regions, solids, or meshes. Here is a demo of how this operation can be used. We create a circle and do a revolve operation to make a pipe bend. Then we extrude another circle to get cylinder pipes. We add a few planes to bound the created pipes. Note that we don't need to precisely set plane bounds or cylinder heights. Then we perform a sculpt operation on the created surfaces and get a single solid pipe. All redundant parts are automatically removed. Now we create an elliptical arc, revolve it, and perform another sculpt operation. We effectively made a fillet operation using sculpture. All redundant parts are once again automatically removed.
In ODA, there are features that are based on top of other features and complex algorithms. Model documentation is an example of such feature. This year, we added and fixed new commands. All section modes are now supported. For section and detail view, support of materials and colors was implemented. Currently, we are working on section and detail view optimization and hidden line removal algorithm optimization and fixes. Now let us illustrate view-based view section and other commands. View-based command. First, we create a base view. We can exclude a part of the model, and as you see, the base view is updated correspondingly. Next, we create orthogonal and projected isometric view. Next, we create a section view, AA, switch to the model and modify it. As you see, the views changed. Next, we'll illustrate how to change the appearance of the views. Currently, we have a base, a section, and a detail view. Let's create a projection view. Next, we change the parameters and create one more projection view. As you see, two projection views look different. We can also change the text position for section and detail view using commands. Now let us have a look at a sectioning example. Let us create two section views, AA and BB, and a projected view for AA section. Now let's edit the view, select the BB section and modify the section in depth. Then perform the same modification for AA. As you see, the corresponding projection view changed as well. Another advanced feature of DWG support is revision control. Branch merge is an essential part when working with revision control. The more agile this mechanism is, the more predictable and expected result we can get. Thus, this year, the key focus was on this part of revision control. In older version, you couldn't get the list of conflicted objects before the merge. Additionally, merge procedure influenced the whole project. Now it's possible to get the list of conflicted objects before the merge, and the merge policy became more agile to apply changes to a particular object only. The new merge implementation provides an extended conflict resolution policy that helps to get a wider list of results during conflict resolution. Let us have an illustration of a conflict for a ODDBM text object and make a merge decision in runtime. We got two branches. One changed the text color, the other color and year text. We make a merge and get the following conflicts. Conflict 1, the first text. As color was changed in both branches. The first time, we select Prefer My Changes and combine the new font style and the new text color. For the second conflict, we select My Changes only and get 2021 text with no color changes.
DWG vertical extensions allow the advantages of DWG to be leveraged for additional areas, such as architecture, civil, map, and mechanical. The first three are used for the following tasks: architecture, design, and drafting, civil design, and working with GIS data. These areas are interconnected, while mechanical stands aside. ODA Mechanical SDK is a toolkit for working with industrial standard drawing elements, such as balloons, part references, surface texture symbols, taper edge symbols, etc. It is developed as a SIG, or Special Interest Group project. In total, we support 22 entities in 7 standards. And we support objects from versions 2013 to 2021. This year, we added support for a new version of the mechanical DWG format. The new version contains new symbol standards for welding symbols. This includes new weld surfaces and new types of visualization. Also, new internal versions of classes are used to convert mechanical objects to older versions. We also modified the class hierarchy, excluding ODDB database mechanical. Now it is necessary to use special functions from the ODA mechanical namespace to convert a database to mechanical and for switching between modes. We have made a number of improvements: new methods for the Bill of Materials Manager, improvements to existing methods, and visualization of Bill of Materials related objects. Public interfaces have been extended with many new methods and now have more options for interfacing with mechanical objects.
My name is Robert Graebert. I'm the CTO of Graebert GmbH, a founding member of the Open Design Alliance. Graebert develops DWG-based CAD products under the ARIS brand and has the second largest DWG CAD user base. We are uniquely positioned in the market with our focus on providing our CAD solutions on desktop, mobile, and cloud, with a consistent set of APIs for our development partners. Our partners are segment leaders, and ARIS is, for example, foundational to DraftSight by Dassault Systems, Onshape Drawings by PTC, and CorelCAD by Corel. In addition, we partner with vendors all over the world to deliver vertical solutions based on ARIS. DWG is core to our offerings, and we leverage the Open Design Alliance toolkits for all our products. We also participate in all special interest groups that extend DWG support to specialized domains: Civil 3D, Map 3D, and Mechanical. We decided to participate in each group as the additional toolkits allow us to interoperate with other solutions in the market in each vertical. In addition to DWG, we also participate in the BIM-RV Special Interest Group for the BIM features in our products. For BIM, we're focused on rethinking drawing production in a BIM world. We consume 2D and 3D geometry from IFC and Revit models, and then leverage BIM properties and the full breadth of our CAD features to provide tools for creating automated and associative drawings for your models. Today, I will focus on a different challenge we solve with the Open Design Alliance toolkit: maintaining legacy drawings in the product design market. New product design has migrated away from DWG-based solutions, but drawings continue to be a key workflow in the industry. When we talk to customers, there's a huge need to maintain part information in drawings. In our estimation, there are billions of DWG part drawings that need to be updated for products that are still being manufactured or in active maintenance. This insight was the initiating idea for creating Ares Mechanical. Ares Mechanical extends the DWG editing capabilities of Ares with special features for the objects originally created with AutoCAD Mechanical. This includes part information, bill of materials, and standard-compliant parts and annotations. These objects are all interrelated and contain a lot of hidden complexity. So why is data compatibility with AutoCAD Mechanical so important? The part information in these drawings is not static. It is not sufficient to only visualize all balloons and bill of materials. It is also important to access and edit all properties of the reference parts. Unfortunately, pure DWG support by the Drawings SDK is not enough. Applications built on top of the DWG format have persisted a lot of business logic in so-called custom objects. This means that without full support of the AutoCAD Mechanical objects, updating of part information is not possible. Developing AutoCAD Mechanical compatible libraries is the task of the Mechanical Special Interest Group. The team has been working on building out support for reading, rendering, editing, and writing of mechanical objects. Throughout the development of Ares Mechanical, we work with all areas of the mechanical libraries, and I can give you an inside look on what works really well today and what are areas that are still in progress. Import, export, and rendering for the supported versions of AutoCAD Mechanical objects is working really well, but not all versions of AutoCAD Mechanical are supported at the moment. More support is coming. DXF export and import is currently missing, and for some modules, we're the first company using the APIs, and public APIs are still being extended as needed. I can say that we're working in close collaboration with the development team, and I want to thank everybody for their effort. One of the benefits of the Special Interest Group model is that all SIG members benefit from our testing and bug reporting and can leverage the libraries today. If you interact with product design files, the libraries developed by the Mechanical Special Interest Group are essential. Please consider joining this and other special interest groups. More members mean we collectively make faster progress and have access to better libraries, can unlock this data and provide better products to our customers. Please reach out to me if you want to discuss our experiences with the special interest groups, and if you're interested in licensing our CAD tools for mobile, desktop, or cloud to kickstart your development with the ODA platform. Thank you, and please enjoy the other presentations.